In this video, we'll talk about hydrogen bonding and how it takes place and really try to give you a visual picture of what's going on there. So we have a water molecule here. We have the red is oxygen and the white are hydrogens. We have H2, then the oxygen, H2O. When we look at a water molecule, it is a polar molecule. That means that one side has a positive charge and the other has kind of a negative charge. We call it a dipole. In this case, oxygen's more electronegative than the hydrogens. So this is going to be the negative side, and this is going to be the positive side. It's polar, it has poles. If we look at the surface of the water molecule, kind of a force field extending around it because of that difference in electronegativity, we have our negative pole up here and our positive pole around here. This gives us this idea that the water molecule kind of has sides to it. That's really important. Let's take a look at how that plays out with just two water molecules. So we have these two water molecules and they're kind of frozen in space here. And we want to see how they behave in an actual sample of water. So we're going to let the computer simulate that. First, I'm going to optimize the model so it lines them up. We do that. We have a hydrogen bond here. Next, I'm going to set the temperature. Let's set up a simulation. Let's leave it right around room temperature. And now this is what we kind of think of as how water molecules are behaving in a sample of water at room temperature. Kind of crazy. They're moving around, they're spinning, and that's just the energy that's in the water there from the heat around. And they do stay together though. This hydrogen bond, it's breaking and reforming, but it stays consistent and holds them together. Every once in a while they start to move apart like they might evaporate, but it keeps them together. Let's turn the temperature up and see what happens. So now I'm going to take it up to about the same temperature as a Bunsen burner. That's a lot more energy. Remember, hydrogen bonds aren't really that strong. Compared to the oxygen and the hydrogen bond, covalent bond here, a hydrogen bond's pretty weak. Let's take it up to about 800. That's a Bunsen burner. And you can see that when we've done that, there they go. They just can't stay together. There's too much energy. In essence, you could think of that sample of water, that very small two-molecule sample of water, is either evaporating or turning to steam. Let's take a look at more water molecules, though, and see what happens. So here's a sample of a bunch of water molecules, and I'm going to put the hydrogen bonds in. And you can see how those hydrogen bonds, they form that network that really holds the water together. If we're thinking of a glass of water, this would be throughout the entire sample. Next, let's give us some energy here. Let's take and put it right about room temperature and see what happens. So there they are. These are our water molecules, and they're all kind of holding together. If you look at any one water molecule, you'll see that the hydrogen bonds are breaking and forming, but they do stay kind of attached together. When we think about the properties of water, it's cohesive, there's surface tension, it has a higher boiling point than similar liquids that don't have hydrogen bonding. The hydrogen bonding has a lot to do with how water behaves. Let's heat this up, see what happens. Let's take it up to that 800 degrees again. There we go. And you can see that when we do that, at 800 degrees, water is going to turn to steam. Those hydrogen bonds just aren't strong enough to hold it together, and it spreads out and forms a gas. So one interesting thing that happens because of hydrogen bonds, when we have water that is frozen, it takes a regular pattern. These are crystals, and a lot of that has to do with our hydrogen bonds here and how the water molecules are lining up so the positive and negative sides can be pointing at each other. So you see the hydrogen bonds here in our crystal of water. This would be moving a little bit as well. These molecules would be moving around some. A lot slower though because there's not as much energy there. This is Dr. B. I hope this video has helped you kind of visualize those hydrogen bonds, that they aren't quite as strong as ionic or covalent, but they're very important bonds, give a lot of properties to water and to other compounds that exhibit hydrogen bonding. Thanks for watching.